So today we're taking a look at section 11.4, which is focusing on two-way tables. And two-way tables are as shown. This is an example of a two-way table. It essentially includes two criteria and the various combinations of those criteria. So the criteria in this one are class and mobile access. And the two classes are freshmen or sophomores. And the question on mobile access is whether or not they have it, meaning yes or no. So if we read this, you can look at it and say, all right, well, there are 55 freshmen who do have mobile access, 63 sophomores that do have mobile access, and there are 22 freshmen who do not have mobile access and 12 sophomores who do not have mobile access. So reading the two-way tables is relatively straightforward, and we're going to go ahead and talk about the various things that we can describe in our two-way tables. So the first thing we're going to look at with our two-way tables is something called a joint frequency. And the joint frequency can essentially be thought of as being the union of two of our criteria. And when I'm describing the intersection of two of our criteria. So when I'm describing this intersection, it would be the intersection of people who have mobile access and who are freshmen. So this is a joint frequency, just as there's a joint frequency between the people who do not have mobile access and sophomores. So 55, 22, 63, and 12 are all joint frequencies. And you may be saying, why do we even need to have a term for what the table has in it? Well, these tables oftentimes have something else on the edge of them, which is very, very helpful to entirely interpret the table. And that is what is known as a marginal frequency. And I totally just spelled frequency wrong. Frequency. It's supposed to be Q-U-E-N-C-Y, although obviously you can look at the one above it because I spelled it correctly there. Anyway, there's no more numbers to circle on this. And you could say, well, is it 55 plus 22? Or maybe 55 plus 63? And the answer is that is the case. But in order to demonstrate that, we're actually going to draw in some more areas on this table. So over here, what we're going to have is a total. And the total is adding up 55 and 22, which in total are 77. And likewise, we have 63 plus 12 is 75. And then we're going to do the same thing on the bottom here. Make this one a little bit, I was hesitating trying to decide how large I wanted to make it. We're going to make it a little bit smaller in size than the other one. But this one too is also a total. It's 55 plus 63, which is 118, and 22 plus 12, which is 34. These numbers over here are our marginal frequency. And one way you can always tell the difference between a joint and a marginal frequency is that marginal frequencies are in the margin of the graph. That was the reason why I didn't have them initially, is because they're generally not exactly part of the two-way table, although it's really useful information to have. But these here are, in effect, in the margin. So they are our marginal frequency. And there's actually one more thing I'm going to fill in, which is essentially in the margin of the margin, but it's simply the total number of respondents we had to whatever we were doing. And in this case, that is 152. And that can either be found by adding 75 and 77 and 75 together, or 118 and 34 together. That gives us the total number of responses. Now, there are a number of other things that we're able to determine from looking at one of these tables. And these are relative frequencies. And the relative frequencies, I'm going to go ahead and make in a different color, in that different color, we'll go ahead and make it blue. And then we're going to have equations that'll tell us where these relative frequencies come from. So the first one is our joint relative frequency. And our joint, whenever we have a joint frequency, we're essentially looking for how common is something relative to the whole. So a joint relative frequency is the ratio of a frequency that is not in the total row or total column to the total row or total column. So essentially, it's joint frequency divided by relative frequency, or divided by total frequency. I'll actually do that in blue. So it's joint frequency and then that is divided, and we'll make our total one over here total frequency. So our joint relative frequencies are any of these red things divided by this dark blue one, more of an indigo color that's in the corner here. So it's just the intersection of our two options divided by the total. So if you were to look at an example of this, it would be something like, all right, we would have 55 freshmen who have mobile access, and then that would be divided by the total of 152. And that would give us a percentage of 36.2%. So 36.2% of the student are freshmen who have mobile access is what this is telling us. All right, well, let's look at another type of frequency, of relative frequency, and that would be our marginal relative frequency. So our marginal relative frequency is equal to the marginal frequency. I'm going to abbreviate frequency because I'm running out of space here. And that is once again divided by our total frequency. So as an example, we can say, all right, well, we have 118 students who have mobile access. And that is divided by the total number of response students, or the total number of people by access, which would be 152. And that gives us a percent of approximately 77. Oops, 70. Okay, I put the dot in the wrong place. 77.6%. So we can say that 77.6% of the students have mobile access in one way or another. So that is our marginal relative frequency. It is one of the green entries, one of the margin entries divided by the total. And then we have one other final relative frequency. And this one is probably what I would say is the most difficult to think about. And that is our conditional relative frequency. So a conditional relative frequency is equal to a joint frequency divided by a marginal frequency. So as an example, one example of a joint relative frequency would be to say, all right, what percentage of sophomores do not have mobile access? And you'd look at your table and you'd say, all right, well, there are 12 sophomores who do not have mobile access. And relative to the total number of sophomores, there are 75 total sophomores. So it'd be 12 divided by 75. And that would tell us that in total, 16% of sophomores do not have mobile access. And that's really all there is to reading two-way tables. So there's actually kind of a lot going on, although if you look at this, essentially what we've done here is we've just sort of like exhausted all of the available combinations across the three different types of entries we have in our table. We have marginal frequencies, and we see how the marginal frequency relates to the total frequency and joint frequencies. We see how the joint frequencies in red relate to our marginal frequencies over here and our total frequency. So we really are just looking at these different vocabulary words to tell us what we're looking for. The other thing I'll mention about two-way tables, and we'll probably do an example of this in our example video, but two-way tables don't necessarily need to just have raw entries in them. Potentially what you can do is you can also present the data using percentages of the total. So instead of having, say, 118 here, we could have had 77.6. And instead of having 36.2 right, instead of having 55, we could have had 36.2 right there. Stuff like that would have been options instead of just writing down the actual numbers relative to the total number of survey respondents in this example. So in the next video, we're going to take a look at constructing a two-way table given a word problem. And that's one thing about statistics is most of the time we're going to end up with word problems. But we'll come back to that in the next video, and we'll also convert our two-way table into the percentage form as well.